Hi there, welcome back. Today we're going to talk about the event-driven payment exception handling. So if you remember in my past posts and YouTube, mostly I focus a lot on the event-driven architecture. And also I touch about how we help the customer to modernize the payment platform using the same architecture in one of my posts. So today I'm going to further discuss about how can we use the same architecture to implement and realize the payment exception handling, especially using Kogito business decision service and the business automation service to help us to automate some of the payment exception handling and to allow human to actually come in to do checker maker kind of approval on the exceptions. So it'll be the same in the past. I always have a post article on the blog site, and with this in this video, I actually will go through the complete demo of what I have done for this payment exception handling, as well as I will have the complete demo source code that is available in the GitHub. Let's go into the details of these whole things in the next session. So before we go into the demo, I want to just take the chance to actually go through again what we mean by payment platform modernization with event-driven architecture. So if you notice, this is the post that I have published in the November 9. Talk about some of the things that we discuss with our customer on the payment platform modernization, right? So if you come to this section, actually I have a definition of what is event-based payment architecture. So it actually center around treating the payment transaction as an event occurrence where multiple participation system or services react to these events, right? So if you see each of these payment coming in and each of these system that actually produce or consume are actually centered around this event streaming component, right? So this could be Apache Kafka or whatever, right? So then the next thing is talking about um, so each of these service and so-called component or system actually react to this event to perform their necessary processing in order to fulfill the payment transaction, right? Each of these service is decoupled, so they should be running individually, independent with each other because all the interaction of data is actually through the event streaming, right? It's not in between these services. And so independent and while still being able to work together to support the payment system as a whole, right? So this is what we're looking at in the event-based payment architecture. So that's about the event-based payment architecture. So next, we want to look at some of the high-level information about what we're going to cover in this demo itself. So let's head to some of the diagram. So in the payment demo that I'm going to showcase, um, yeah, it's actually follow the demo flow in here. Or if you look at here, this is the start, and then from the demo that you're going to see is that we're going to submit the CASA transaction to the postman, and then from there it actually sent to the Kafka, right, in the topic. And from that topic, there is two services in here actually will consume this topic and do a necessary processing, right? One is the chat limit or chat credit. One is the chat fraud service. These are two Cogito services that actually will perform the necessary validation. Chat credit will actually check things such as like whether this amount exceeded the daily allowed daily transaction limit or whether this amount exceeded the available balance in the fund, right? So if this is a transaction that is not valid, a false condition will be returned, right, and sent to Kafka as a messages in another topic. Same for the chat fraud. Basically, chat fraud will actually check whether the transaction actually have violation on example, violating the so-called the transaction limit enforced by our central bank. For example, if let's say the amount is more than 50,000 that is enforced by central bank regulated limit, then it will return false, right? So in this case, these two results coming back will actually send into a different topic in the Kafka. So we have a service here actually will do a aggregation and consolidation of this validation result from these two different topics. So our consolidation services will be able to process this multiple result from multiple different kind of check and consolidate this into a single result. For example, if this is check credit is false, check fraud is true, the result should be false. Only both are true, then only the validation result should will set to true. So with this consolidated result, you will actually send to a Kafka topic again. So how does it send is that you in this implementation, basically this is a Kafka Stream API implementation, right? So it based on this different result, and what it does is that if this transaction is valid or is validated, it will send the payload to a Kafka, which will actually consumed by the core services, and then the core services will perform the necessary credit and debit. If this transaction is not valid, that means probably two are false or one of them are false. So it will go to exception handler, right? So in the exception handling, right? So we have a flag to say that whether this is allowed exception or not. If this is allowed, then it will raise an exception in here. So this raise exception in here will actually send a message to another Kafka topic that will actually consumed by one of our exception handler, which is Kogito business automation workflow. So this will have a human task where someone, like example, the payment officer, will actually come in and do a necessary review and approve or reject this exception. From the result of this approval, whether if it is approved, that means this message will actually send to a topic that will actually consumed by core, and the core service actually can perform the necessary credit and debit. So if this exception is not approved or rejected, so what it does is that it will log an audit, and then this audit will send to a Kafka topic. At the same time, the same message will actually send to a Kafka topic that will actually consume by the casa, right? So the casa will actually consume one of this topic and say that okay, this transaction actually is rejected. So this is how the overall flow of the demo itself. So next we're going to look at one of the architecture that we have, and you should have seen this in the post itself and also in the GitHub. So basically, this is overall architecture for the demo. And in this, this is a outbox pattern implementation for Casa service. And basically, I have covered this in one of my previous posts. You can refer to that for more detail. Same for the core service here. So I'm not going to touch these two. And in the center, you will see there is a Red Hat MQ stream as the Kafka streaming so-called central of all the events occurrence and so on. So if you look at this diagram, all the services are actually interact with each other through the MQ stream in this case. And there are quite a number of things that we actually introduced in this demo, extension to the previous demo that we have. Obviously, the things that I want to focus today is talking about the Kogito services. So in Kogito, we have two types of services, the decision service and also the business automation. So for the decision service, actually, if you look at the process flow just now that we look at, there's a credit check and fraud check. These are two that actually implement using the decision service. And then based on the result, we have Kafka stream that actually perform the necessary consolidation of the result of this two validation. So we have supporting camera service that will need to be in place. to help us to do things such as like data enrichment and so on. So for example, in our fraud check and credit check, we'll need additional information such as like daily transfer limit, um, and the account balance in order for us to perform the credit check and so on. So this validation camera service will help to enrich that information from the original message that is sent in by the CASA service. So in the other hand of this part, you will see that we have things such as like the Kogito so-called services as well. In here, you will see there is an exception handler. This is the Kogito business automation services. So this is where our workflow and human touch is. So you'll see this demo in the next section where you'll go through some of the UI, how we actually can use this to approve and reject the payment exceptions. And supplement to this, we also need to have certain level of management console and so on, and data services and persistency services to be able to help us to monitor our workflow and process instance. So this is where the Cogito persistency and the management services coming in. So in the demo itself, when you deploy that demo, you will have a number of so-called services available. So you'll see things such as a Cogito Infinite Span and Cogito Data Index. So these two will actually provide the necessary persistent information that is required for you to look at the process instance, the relevant process data and information. We have two management console in here. One is the Cogito management console and the other one is the task console. So these are two UI that allow you to monitor and look through and look at your process instance. Where am I now for my payment approval and so on. And you can actually go to here and drill down the process instance information and so on. We also introduce or put deploy a key cloak here. So the key cloak actually basically just to provide authentication service for the Cogito management console. So basically you need to log into the key cloak to be able to access to the console. So the demo not very much focus on the access control and role-based access control, but basically Cogito management console and Cogito services and the workflow that you can actually implement all this by just enhance the implementation. But we are not going to go into that detail for that part of the demo. So that will actually cover the complete demo for today. So okay, that's all for this section. Let's head to the next section for the demo itself. So I'm going to go through the front end demo first to explain through how can you navigate on this demo. And in the later part of this video, I'm going to go through the backend side. That means how all this is being implemented from a technical perspective. So if you look at here, this demo actually deployed into the OpenShift. In the GitHub itself, I have created a deployment script, a bash script that actually you can just execute and deploy the whole complete demo onto the OpenShift. So in the deployment, you will see there are three projects created in here. One is the apps. So this is all the pod that is running or the pod for the application itself. In here, we see that is about the 17 pods or services that is running here. There are databases, there are Kafka Stream API implementation as well. So in the other project, we have a Cogito, right? So Cogito in this project, basically it hosts some of the data services that is required to provide persistency for process flow and also for the data itself. So if you can see here, we have data index, um, the infinite span, and we have management console and the task console, right? So we'll go into this later on. If you see here, we also have a key cloak here, which is provide a small scale of authentication services for the management console itself. So in the next project, which is the Kafka, in the project of StreamZ, we have Kafka and Zookeeper that is running. This is quite straightforward. Let's back to the apps. So we have three so-called routes that is exposed here. So we have audit UI. So audit UI basically provide a user interface for you to go through or produce report for audit trail. So I have actually touched quite a bit details on how to implement audit trail using outbox pattern in my previous post. So you can refer to that post for more details about how this is being implemented. So in this demo, I extend the audit trail to cover a lot more modules. So if you go to this Casa service URL, right? So you have to append a Casa slash all here. This is returned from the database. So you can see all this status is complete. If there's any problem, you will see that the status actually is at the submitted status pending from the processing at the backend. So we have another UI for the so-called exception handling. So this is implemented using the so-called our Kogito business process itself. So next, I'm going to create a transaction with an exception, and then you will see that there will be a process appear here waiting for some auditor or officer to act on it, whether to approve this exception or reject this exception. So before we go into that, probably it's worth a while to look at what we actually have done for the Kogito decision service and business process itself. So there are three things here. One is the handle exception, the other one is check fraud, the other one is check limit. So what we do in check limit is that we will take the credit details. If you look at the data type here, the credit detail is like this. So we'll take some of this information and then from the payload and then perform certain level or necessary of decision service here. So you can see that if let's say for example credit amount is more than zero, which is true, and balance if the customer account or the transaction account has a balance, and then this will be true. And if the transaction amount is less than the balance available, this will be true, and so on, right? So based on the different kind of situation and scenario, we can actually use a decision table or Excel type kind of configuration to configure our business rule or decision service. So this is the place where you actually specify what is the outcome of this rule evaluation will be, right? So for example, if in this case, if everything is true and fine, our status will be true, indicate that this is a validated okay to go kind of a transaction. So we also pass back some of the information such as like the transaction ID so that we know for this response coming from this check limit service, it is for which transaction that we are talking about. And we also have some level of allow exceptions on. So this is where later on we are going to use for our exception handling. So I'm not going to go through now. And this is some of the things that a cosmetic thing to say I want to record the timestamp of this decision service when it is executed. So in other cases, like things like if let's say validation is not okay, that means, for example, the amount is less than the balance available. So in this case, I will set the status to false, and then the reason coming back will be like balance amount is insufficient. So you can see before even this transaction or data going to the backend, such as like core banking, we already have a capability to be able to do this kind of credit check validation in the first few front stages of the transaction. So this means that you can cut short a lot of this processing, right? You don't have a situation that where this transaction, when it go to core banking, then only you realize that maybe balance is not enough and so on, right? Then you have to reject the transaction. That is going that is happen after going through so many stages of the so-called payment. But in this case, this is just a first stage. We already catch all this so-called validation issue and so on. So this will help you to actually have a better performance, it's cleaner kind of implementation for chat limit and chat fraud. So in the chat fraud itself, we also do a similar thing using a table kind of so-called decision service to do certain different scenario kind of implementation, right? So if you can see here, we have certain like origin country, we probably don't not okay with some of this original country, and then we are not okay with some of this destination country. And we also have like transaction amount, if let's say more than 50,000 per today, and then this will be something that is fraud kind of cases. So in this, we also use a status to set a different status as a response. And we also put up some of the messages to respond to that transaction itself. So you can see this is quite clean cut. So as some of business analysts or whoever, you can actually do this quite easily. So the other one is the handle exception. So this is a workflow. So if you can see here, so these are when everything the validation has been fine, or if let's say validation has a problem, let's say transaction more than 50,000 per one, and of course, immediately in the system, based on the event-based kind of processing, that exception will be raised. And you can see here, we actually read from the Kafka topic. So we read from the Kafka topic and raise an exception and kick off the workflow here. So this is, if you see, this is a human task. This is where someone need to come in and approve or reject that exception. And if let's say approve, then you will do certain necessary kind of message or data massaging and then send to a respective Kafka topic again. If this is a rejected exception, so it will send to another different type of topics for further processing or respond back to the so-called the Casa service. So this is a workflow. So let's back to here. So let's try to create one um, transaction that is okay without any issue. So now let's say I want to buy a shoes, right? So it's about 210. So I say this is, I want to buy an Adidas shoe, and when I buy, I need to pay for someone. Okay, so this is the transaction detail. I'll post it to the Casa service, and you see that this is submitted here, and you 19346 is the transaction ID. So if you come to here, I bet you will see that it is submitted now. So it's still being processed by the backend. So what happened is that if we come to here, let's see if there any is there any 19346. So okay, just a few seconds ago, now we see actually it is completed, right? So you can see that Casa submitted at this time frame, and then validated by the validation services, the Kogito decision service that we mentioned earlier, and then it's actually consumed by the core service at this time frame, and everything is fine, that is completed. And then this is a response received and captured and processed by the Casa service again, which is a status of completed. So now we see that completed status is coming back. So if we refresh again, we'll see that, okay, the status is completed. What is the response time and so on. So this is a best scenario without any problem. So let's say, example, we want to transfer a bigger amount and maybe just buy a guitar or something, right? So it do a transaction here, 94216213. So you can look at here, okay, 94213, the status is submitted here. If you look at our limit here, you will say that this is the minimum is 50,000, right? So we are actually more than 50,000 here. So what happened is that if you come to here and you do a refresh, an exception has been raised. And in the typical scenario, you will turn on notification, you will have an email notification to send to a respective officer. And when they receive that email, they can click on the email link and come to here and do necessary processing. So if you look at here, click on the details, we can see the transaction ID, the account number, the recipient account, what is the transaction amount, status is rejected, and why. Okay, so the reason is exceeded daily transfer limit, transaction amount exceeded central bank regulated limit. So this is the message that actually produced from our decision service that we have configured just now. Okay, so let's see what our um, audit trail say, right? So this is that's labeled 94213, 94213, which is this one, guitar, right? So we can see that now the audit trail captures is that, okay, CASA is actually submitted this at this time frame, and there is a rejected status here. Why? Because the validation services actually say no, you exceeded the daily transfer limit. So you can, in this case, you have a very clear tracking and tracing, being able to know what is happening at the back end and so on. So this is up to your implementation, how much of details you want to capture for your audit trail in this case. So in our case, obviously we also have, before we go to approve or reject this exception transaction, let's go to the Kogito service again, right? So if you look at here, this is a management console. So in the demo itself, we actually set up a simple one, which is the user ID is admin and the password is admin. So when you sign in, you will see, okay, there is one process that is running now, and there's no child process. And if we click on here, we can see, yeah, so the transaction actually stop at the human task, which is approved exception, waiting for someone to act on it. So this basically is a admin console that you will protect so that only certain admin or supervisor will be able to come in and look at the process itself. Of course, there are quite a lot of other things that you can implement with the so-called Cogito management console and process instance like SLA and all these things. But today I'm not going to go through into details about this. So let's head back to the exception handling here again. So let's look at the task, what we have. Okay, so when we look at this, and why so expensive? So this is really suspicious. So what we do is that, okay, we'll just reject that. This was actually sent back to the Kafka uh, topic again, another topic in the Kafka. So the streaming happening, the processing happening at the backend now. And if we try to check the status again, right? So we can see, oh yeah, so you respond back to the CASA service said rejected. So all this is actually, you can actually have this information or status being like an email, SMS, or apps notification to your consumer, right, to your customer itself. So then they will know that why this is rejected or is this transaction has been completed successfully. So if we go back to the audit trail again, refresh the data 94213, this is where the huge amount of transaction that is happening. So you look at here, yeah, so now we have new audit trail that is coming in, right? So there is exception, there is a audit trail entry by our exception handler. So if the status is rejected, and remember, we actually put in a comment say, this seems really suspicious, right? So this also captured in part of our audit trail. So when this response is actually produced, it actually produced in the topic that is actually monitored by the CASA service again. So the CASA service will actually capture this and say, respond back to the so-called the consumer or end user to say exceeded daily transfer limit and so on, right? Obviously, what type of a message or reasoning that you want to respond back to the consumer and so on is highly customizable. It depends on how you want to implement it. In my demo, I just make it simple. So if you head to the GitHub URL, so you will see this is the main project that I have for all the tutorials that I have posted on the blog site. So the particular project that you will be interested in this demo is this payment exception handling. So when you clone this down, you will see this is the structure of the source that you will have some instruction there on how the process flow looks like and the overall architecture, which actually cover in my post as well. So this is some of the instruction of how you can deploy this project into OpenShift and try it out yourself. So you need to make sure that you have the Red Hat MQ stream operator installed and wait for it to be ready. And log in with with a cluster admin and just deploy the demo itself. So some of the things that you can change is I also put it up here. So in the respective um, call service and also the customer service, it has its own sample data. So this is the sample data that is already provided. And when you run the deployed demo itself, this sample data will be imported into the database. And you can actually add in more just to um, make your demo more have more variety of different type of accounts. And so this is what you can modify in the import.sql for both the customer and the call service, right? So when you after you modify this, when you do the deploy.demo.sh, it will actually pick up this file and import into the database. The only thing you need to make sure that is make sure your account ID is matching between the call and the customer, right? So this is how the relationship is. And you can have any type of account number, right? As long as they are unique, okay? So when you do the deployment, you probably will have some problem when you do the deployment. If you encounter error such as this, right? Pipe close. So this is a known issue with the Quarkus OpenShift plugin. You can actually refer to this reported issue here. Basically, this is a random error where the connection is closed too early during the deployment, and you will see this. Sometimes the app modules will be successfully deployed and running. You do not need to worry about it, but sometimes it will just fail in the halfway without deploying the apps. So the current recommended approach to deploy the Quarkus is using the S2I. But the S2I require each of our apps module to have its own Git repo. So for a demo so-called purpose, right, it's not practical for me to maintain each repo for each of the module. And if you notice, I have around 17 modules today. So if I have to follow the S2I approach, I have to create 17 Git repo in order to deploy using S2I, which I'm not intended to do so. So in order to help you to deploy or overcome this problem, I've actually built in the script for you. So if you encounter this error, the script will actually stop. So what do you need to do is just run this command again, right? But specify -m apps. This will tell the script to retry to deploy the apps module again. So for the previously successful deployed module, it will be skipped. For the module that is not successfully deployed, this script will actually attempt to deploy it again. You probably will have multiple occasion or multiple times of this problem when you run this command. You just have to try or run this command multiple times. From my experience, I maybe need to run 2 to 3 times to get all the app modules deployed successfully, right? So in this case, with this, I think I help you to cut short the problem to deploy the apps module. You don't need to do it by hand. So you have to follow the sequence once this problem came out. First, you do this, deploy the apps. Try this until all the module has been deployed. The second is to import the sample data by running this command. The third one is to deploy the Kafka connect and the connectors by running this command. And the last one is to run this command to expose some of the routes that we are going to use in the demo itself. So these are the sample of the problem that will be encountered if you are trying to deploy using the Quarkus plugin for OpenShift. Okay, so that is about the deployment itself. I made the deployment step pretty simple for you. So now let's go to the code itself, the sample codes. So once you have downloaded this source code to your local disk, right? So this is what you're going to get. Um, I'm showing in my Visual Studio. So this is the payment exception handling folder. So you have the bin, which is the deployed demo.sh, and we have some of these config and modules, right? So let's go to the config first. So these are the location for the Kafka connector configuration data, right? So these are the same, um, similar to the previous outbox pattern post or demo that I have. So nothing changed in here. I only changed the MongoDB connector configuration to add in this extra configuration, right? So basically what I did is that by specifying this configuration and modify the MongoDB to use the ID as the unique key, the ID actually is the transaction ID. So by doing this, I'm actually asking the MongoDB connector to apply subsequent changes or incoming audit messages to the existing um, so-called records in the MongoDB by comparing the ID or the transaction ID um, in the existing records. So what happened, why I need to do this is that if you notice in the earlier outbox pattern, we only have two type of event, the CASA event, the CASA audit event, and the core audit event. And these two can happen in very quick manner, and the audit event can occur in just a sub-seconds and so on. And the connector will have no problem to actually catch this and produce this or stream this into the MongoDB. But in our new cases in here with the Kogito, with the exception handling, the exception can be approved or rejected in the next day or the next 2 days, which the message will be only available after 2 days or 1 days. So that is not ideal for our situation. What we need to do is that being able to captures all these audit event for the same transaction and update the existing records in the audit DB in MongoDB with the right transaction ID. So this is how we do it. So that is about the connectors. In the modules part, we have quite a number of new introduced modules here. Audit log aggregator is the one that exists from the last demo itself. I'm not going to touch about this. You can actually go into the code and look at it itself. I've done a several enhancement to that to capture additional audit trail from the credit check limit, the fraud check, and also the exception. I've introduced an audit UI, Quarkus UI, where if you see in the previous demo, right, you can actually go to this UI and look at the audit trail. Casa service is the same, core service is the same. So I have introduced a limit check. This is the Kogito decision service. Fraud check. This is a Kogito decision service. Exception handler is the Kogito business automation service. So let's go to the limit check first, right? Let's take an example by looking at this source code. So in order to implement limit check, what you need to do is to include some of the Quarkus plugin. As you can see here, um, we need these two Quarkus plugin to implement the decision service for Kogito in Quarkus. And that's all, right? After that, what you need to do is to create a file that is ending with DMN. In this case, I have this file called chat limit. Okay, so this will actually allow me to do a drag and drop to configure my decision service. And how do you create this is pretty simple. You just need to drop in any files, right? So let's say I create another one, which probably I call it my test.dmn, right? So once you enter, the Visual Studio will actually load a UI, allows you to do drag and drop to design your workflow in here, right? So it's very powerful. Okay, let's close this and ignore it. So back to here, I have this decision service that is already created. Beforehand, I will need to define my data types. So I have two data types here. One is the credit detail. Credit detail will captures information from the Kafka topic, such as like daily total amount, the balance, the daily limit, the amount, and so on. And then for the outcome or result of the validation service, it will actually uh, being produced as a result in here. And you can see this is like transaction ID, status, and so on, right? So this is the two data type or data model that I have. So back to the editor, right? So how do I configure or tell my decision service that from which topic that I need to pick up this Kafka message and to which topic I need to send this result to? So this is actually configured in the application properties. So if you come to here, right, in the application properties, you will notice there is an incoming stream and there is an outgoing stream. So this is where you specify from, let's say my example in here is that I want to consume the incoming messages from this topic, opay.chat limit. And once I have performed the necessary decision service checking and I want to produce that result to this outgoing stream, which is opay.chatlimit.response, right? So this is how simple you do it. The rest of the thing is quite standard. For example, how you configure your Bootstrap server and so on, right? So back to the auditor again. So this is where I will specify if you have used Red Hat Decision Manager before, the UI to configure all these are pretty much very similar. For example, I will need to configure my data type to capture my incoming message, which is a credit detail, right? So this is how you configure it. And the next thing I want to look at is the decision service that I have configured as a decision table. So in here, what you see is a chat limit decision table that I have. And this is how I specify based on the input or incoming messages. This is my data model and this is my data field, right? So I want to do checking on the exception, on the amount, on the balance. For example, if the amount is more than zero, which is true, and the balance is more than zero, which is true, and then the amount actually less than the balance that we have, that means we still have balance to perform the transaction, which is true in here, and daily limit actually less than the total transaction that we perform today. So everything is true. That means this transaction should be past our testing and being able to go to the next so-called stage of the transaction or the payment. So then what we do is that in the result itself, we actually configure to say, okay, for my result in here, I will say for my status, I will set it to true, right? The second row here. And I'll pass along the transaction ID that actually I captures from the Kafka topic so that in the next skin of the processing, because this message will actually produce in the Kafka topic and consumed by the next services. So the next services will need to know, right, which transaction that this belong to. So this is how I pass along the transaction ID. And there is no reason or rejection happening, so I don't need to put any reason for a case that I probably have like false. False means that this payment transaction is not passing the check or not valid. So then I need to put in a message such as balance amount is insufficient and so on, right? So this is how you configure the your decision table. And of course, in here you can do a lot of other configuration, which I will not cover very detailed into it. So let's go to the first column again. If I click on here, there is a hit policy configuration where you can actually specify right, how this decision service rule should be evaluated. In my case, I just want to make sure whenever the first rules that actually met the condition will be actually fired, and that will be the result that I want. And in other cases, you probably have a decision rule that actually need to be able to um, set by priority, or you want to have a collective of rules and so on, right? So you can configure the different type of a policy in here. which is similar to the traditional Red Hat Decision Manager that if you have done that before. Okay, so let's close this um, and let's look at the fraud check. So for the fraud check, the implementation approach is the same. In the POM SML, we are using the same thing. And what we do is that we also create a check fraud .dmn in here, right? So what we do in here is that obviously the data that we want to capture is totally different from the transaction itself. This model, we actually capture like origin country and destination country, right? So these are the information that we need for fraud check and so on. And back to the auditor, if you check the decision service that we have or the decision tables, it will actually based on the origin country and destination country. You'll do certain level of validation and say, okay, for this country, it should be blocked, so the status will be false. Or if let's say the transaction amount is more than the predefined that we have configured here, which is 50,000, then it should be false. The reason is that transaction amount exceeded central bank regulated limit, for example, right? So we have this, if you notice, I have not mentioned about this. This is a transaction exception condition here. This is basically to tell our chat limit and chat fraud decision service to say, if the incoming message have a exception set to true, just match this one and set it to true and just return the result as true. Why we need to do that? Remember, in the next, I'm going to cover the exception handler, which is our business process to handle exception, to approve and reject the exception. So, if in the case of the exception has is approved, the same payload or transaction will be submitted again to the same process to go through the so-called the process again or the workflow again, right? So we want to bypass that. We don't want to check that again. So in the exception handler, we actually set the exception to true in the condition that to ask our check fraud and check limit to bypass this transaction if this set to true. We don't want to evaluate this condition anymore because that is a proof exception, right? So that is about the check fraud. So next, let's go to the exception handler. So in the exception handler, there are additional things that we need to include as a plugin in our pom.sml. So things such as like additional plugin. So it's very easy to notice. If you see this, these are all the Kogito Quarkus plugin that we need, right? So we need additional things such as event process plugin. We need to have persistency plugin for infinite span and so on, right? And if we look at our workflow here, which is in the same location in the resource, same thing. If we want to create a BPMN workflow, we just need to, in this location, the resource directory location, add in a file name end with .bpmn. By creating this file, when you click on it, the Visual Studio Code will actually bring up the so-called IDE interface, allow you to drag and drop and design your workflow itself. So in this case, what you see here is I have a message node here, the incoming or the start node, where actually will take the messages from a Kafka topic and go through the process. And if let's say it's a reject, you will send to the another Kafka topic. If it is approved, you'll send to another Kafka topic, right? So if this is how we actually consume the Kafka message and produce a Kafka message. And in the middle in here, this is the human task, right? So this is a human task where someone need to come in, the payment officer or someone need to come in and actually approve this payment exception, right? Or reject the payment exception. So if you look at the demo that I have showcased in the earlier section, you'll see that when I approve or reject, I can put in the reject reason or approve reason as well. So this is where we capture that information from the process, right? So you can see that in this case, this is a approved situation. So I will set the exception approval to true. I will set the exception reason from what we have captured during the UI approval process or the rejection process. And I also set the event source and timestamp as well. And for the reject here, it is a similar implementation. The only thing that is different is that for the exception approval now we set to false, which is a rejected approval or rejected payment exception. So in this case, it's very simple. The other thing that we need to know is that how do you define again, how do you define the incoming topic and outgoing topic? This is where you define the implementation in here. I will say that for this node, I will use the exception variables, and then for this, I will use the um, exception response variable. So where is this defined? This is actually defined in the application properties, right? So if you notice, we have exception, which is for the incoming, we, which we read the Kafka message from this topic. And then for the response, whether it's approve or reject, you'll go to this exception response and the topic is here, right? So the rest of the configuration is quite standard for the Bootstrap server. And of course, in addition to the what we have seen here, remember we talked about the persistency of the process instance, the task instance, the variables information, all the information related to the process instance. So if you want to be able to persist this information, so you need to do a configuration in this, right? In this case, this is for the process instance with this Kafka topic, right? So all this persist information will send to the Kafka topic itself, right? Same for the user tags and the variables. In addition, we also need to define our data index. We also need to specify our infinite span server URL in here, right? So this is where how you actually configure the Kogito business automation for Quarkus. So there are quite a number of other services that we actually introduced, like the camel service, right? So basically, if you remember, I covered in my post saying that for Kogito, the incoming and outgoing messages actually is produced in cloud events formatted data, right? So for our existing core service and Casa service, we actually using JSON data format. So in order to be able to convert between JSON and cloud events format, which I don't want to change whatever I have done, so I actually introduced the so-called the exception camel service for the exception handler, which help to responsible to do certain necessary of data conversion and the data enrichment. So if from the beginning you already implement the cloud events data format for all your services, then I think you do not need to do this kind of camel service in terms of doing conversion and so on, right? But I still need the camel service because I will need to do certain level of data enrichment, right? So for example, when we look at the fraud check service in here, right? So in our check fraud decision service, I mentioned we have data types such as like this transaction, and this transaction have things such as like origin country and destination country. So this information is not available in the original Casa messages or JSON data that we have, right? Remember in our JSON data, we only submit the recipient account number, the source account number, the amount, and also the recipient messages, right? Reference messages. These are only the four data that we have, and we don't have this information. This information actually located in the customer profile, right? So we also need the camel service in this case to enrich this data so that our decision service will have the necessary data to perform the necessary fraud check and limit check, as well as the so-called the um, exception handler as well. Okay, so this is some of the camel service, why we need a camel service in here. Okay, so we also have things such as like the validation handler. This is a stream API implementation. In here, actually, what it does is that if you notice, we have limit chat and fraud chat that send the response to a different topic with their own data content. So what we need to do is we need to consolidate these two so that we will know that whether if this limit check is false, fraud check is true, our results should be false by consolidating the two results from here, right? So this is where our validation handler coming in, right? So the validation handler will actually read multiple messages from different source of topics and then do the necessary so-called consolidation and aggregation, right, to produce the single one result to say that whether overall whether the validation is valid and good to go or it should be a exception cases. So this basically overall of what the whole thing about from the backend. So you can see this is um, quite a lot of module, but actually it's not tough or complex to implement. Basically, we with the Quarkus, a lot of this implementation has been simplified. So with this, it actually ends the demo that I want to show you about the event-driven payment exception handling. So let me know what do you think and leave me a comment if you think this is something that is really useful to you. So what is the takeaway for this demo, right? So very simple. Um, Obviously, we are still able to stick to our event-driven architecture design to make sure even our payment exception handling will still be able to use our event streaming platform as a center of all the events and messages to capture all these exception that is happening and to act on it to help us to really um, have a better and improved exception handling for our payment platform. That is one key things that we want to achieve. Secondly is obviously with this kind of architecture design, we'll have a loosely coupled and highly scalable services, right? Not only for all the existing services that we have like the CASA and so on, but even the workflow and the decision service can be loosely coupled and highly scalable, thanks to the event-driven architecture that we are talking about here, right? And the good thing also that with the Kogito, obviously we can actually using a low code approach to implement the business rule or decision service, as well as the business automation that we needed in the payment exception handling, right? So that actually conclude the whole demo itself, and I hope you really benefit and enjoy for this long 1 hour demo. So I really want to thank you again for you to staying until the end of this demo. If you really like this video, please like or subscribe to my channels. At the bottom, there is a URL for the blog site that I am maintaining. I keep actually constantly update and post new things and new ideas of how we can actually um, do things better from the technical perspective and so on, right? So stay tuned and subscribe to my channels. Thank you for watching.